Hey guys, this is Gabin once again, and today we'll be doing some work on logs. We haven't finished really, so this topic is huge and very important. So I realized that there are a few type of questions that we actually have to do, and so yeah, let's get started. The question that we have got here is, given that ln of 4 equals 1.3863 and ln of 8 equals 2.0794. So this is down to 4 decimal points. And the question asks us to find ln 32, right? ln 32. So you might wonder, okay, how do I get started? How do I start with this? But remember, in the previous video, we looked at some of the properties of logs, where you have a product, right? Product of two logs numbers. It's basically you can separate that, you can change that, transform that from product into addition, right? So that's what we have to do here, because we have got ln 4 and ln 8, and we know when we times these two numbers, 8 times 4 is 32, which will give this value. But then how do I actually solve or work out the solution or the answer? Now let's get started with that. So my first step, what we'll do is I will write this one, ln 32, so be ln 32 is equal to, use product rule, so other way will be just ln 8 times 4, right? But using product rule, just here, using product rule, we know that this is the same as ln of 8 plus ln of 4. Now ln of 8 times ln of 4, so it's basically those two numbers, which is 2.0794 plus 1.3863, which should be equal, so I will get 3 here, 3 point, I know the last number will be 7, 15, it will be 5, 1, 9, 16, 6 and 1. So I hope this is the right answer, but let's double check, right? I've got my calculator with me here. Let's double check. If I did something wrong, 2.0789 plus 1.3863. Yeah, so there's a mistake here. This is instead of 1, this should be 4. Alright, this is 4, 1. So yeah, this is your answer for that. However, I've got another question also, maybe to be more formal way, you can just do, therefore ln 33 is equal to 3.4657. So this is your answer. However, I've got one more question for you, which is the second part of the video, where we looked at, in this second part of the video, in this second part of the video, what we are trying to do is we are actually trying to convert converting a power function into a log function, and then relate the log function into a linear function. Let's see how that works, because in chemistry, for those who have done chemistry, or those who will be doing chemistry, in chemistry you have, at some point you will be doing a rate of reaction. There are questions that involve log, where you have to convert a normal function into a log function, and then maybe work out the linear function where you're trying to find the rate of the reaction. So let's get started and see how you solve the question if you miss them or come across that question. So this is basically what you will do. In here we have got this power function. I would call a power function. There are different ways of calling this, but then allow me to call it a power function, because we have got just a coefficient and a power really. So with this, what do you do, right? The first thing that you will do is remember the property of logs. We can insert or inject logs on both sides of this equation, right? So let's do that. When you do that, you have log. Remember, I won't put the 10, so basically it's assuming base 10. Log y equal to log y is equal to log a x n. Right, now remember, product rule, property of our logs that deal with product. So we know on my right hand side I'm going to have this as log a plus log of x to the power of n, right? Then my next line, remember what we said the other day, when you have a power, then you can take the power down at the front of the log, it become a coefficient, and then you end up with log base 10x, right? So let's do that. We have log a plus n log x, which basically here left hand side you have log y, here log y, right? So here I have transformed this function, power function, into a log function, right? Transforming that function into a log function, and you can see what I get here. Now think about this. So we have done the first part of this task, right? Which was to convert this power function into a normal log function, which is good, right? It's looking good. Now, as I said on the last part of this, is to actually relate this function. How can we relate this function? How can we relate this function to a linear function, right? Remember the equation of a linear function, right? A linear function, we know that for a linear function, the equation is y equals mx plus c, right? So m is the gradient, this is the variable, and this is c is a constant, right? Can we relate this to this equation? Yes, absolutely. Why? Because if I can transform that equation, if I transform this, this is basically y, so that will be our log y is equal to n log x plus log a, right? Remember now, so this is our gradient, this will be our m. So if we do this, this will be our m, and this is just a normal variable for this will be our mx, and we have plus, this will be our c, just a constant, this will be our c, and that will be our c, and the last file here you have, this is just your y, So this is how you can convert a power function into a log function, and a log function related to a normal linear function. So this is very important in chemistry, because you have to sketch them, you have to sketch the graph of the reaction to actually work out the solution of the gradient if you don't have enough variables or enough information to work out. Alright guys, thank you so much. Remember to like, share, comment, and if you haven't subscribed to our channel, do so. I will see you in the next video.